Okay, Math 10 final exam review. First thing I want to recall about the standard deviation. Not only how to calculate standard deviation, you need to know what does it mean. So standard deviation tells us about the spread of the data. So if I give like a data 1 1 1 1 1 1, or if I give 2 3 1 5 7, or if I give 2 11 2 23 49 79 1 11. So notice for this one, the standard deviation right away I know it's 0 because there's no spread. And this one here will have the largest among those three datas, largest standard deviation, SD for standard deviation. So the first one would have the smallest because the numbers are on top of each other. Next one, there's a little bit of spread, and the last one would be the largest spread. So that's one thing, will help you to solve one of the problems. Next, recall the scatter plots. Scatter plots are the ones that they go like, you have figures. You can have a scatter plot like this, or a scatter plot like that, or a scatter plot all over the place. Right? So the question is, we have what we call correlation. Correlation could be like positive correlation, negative correlation. That's what correlation about. So which one would have a positive correlation? So let's call this figure A, figure B, figure C. Which one has a positive correlation? A. So this has positive correlation. Look at the other ones. What do you think about their correlations? And you can comment in the box. B has a negative correlation. This has no correlation. No correlation. So if we have something like this, so say something like this. First one, this is R is 1. R always, this is the correlation coefficient, we call it. R is correlation coefficient. So R is 1, you get a perfect. That's when R is positive 1. Here R close to 1. This one is, the more the ugly the stuff is, the more it's closer to 0. So basically R can run from -1 to 1. The more the closer the 1, the more the perfect, I call perfect positive correlation. If you go this way, close to -1 equals -1, you will get perfect negative correlation. That's what this is. So if you have something like this, I would estimate this to be about -0.2 or something, and this one is R equals -1. That's about positive and negative correlations. So if I scroll back up to this one, in this case R would be 0. R would be 0. Next, we we let X be the number of points that can be scored on one question of a stat class or stat test. We have the probability distribution of how students did. So we give you a table, X and P of X. So out of 1, let's say, how many, there's some people scored, how many scored 1, 0, 2, let's say 3, up to 3 people. So say the probability is 0.18, 0.11, 0.45, like that will give you this. And we would ask you find the probability of getting at most, let's say 2. So to do that, first thing, at most 2 means 2 or less. So that would be the probability you're getting 0, the probability getting 1, probability of 2. And 0 would be 0.18, 0.11, 0.45. And we add them up. 14, 5, 6, 7, 0.74. No more than 0. No more than 0 is basically just 0. And if you look on the table, it's 0.18. C, they want us to find the expected value of X, E of X. The way you find the expected value, you call it x1 times p of x1 plus x2 times p of x2 plus etc. depending on how many. So x1 is the first value in the table, which was 0. 0 times 0.18. So 0 times 0.18. The next one was 1 with the probability 0.11. Third one was 2 with the probability 0.45. 3 times some probability, I don't know what it is, it's not listed in the table. But let me scroll back up. To get this missing one, all these probabilities, they have to sum up to 1. So if we take 0.18 plus 0.11 plus 0.45 plus some x value is 1. If you solve for this, I get 0.26. So this should be 0.26. So 3 times 0.26. Now we have to do the computational part. What do we get out of this? $1.79. Make sure you calculate it and make sure your answer matches mine. Another thing to know, another example, we have given two independent, actually let's dependent, two dependent sets A and B. A and B. So let's say there is a data with each set 2.3, 5.7, 8.1, 4.4, 4.6 or 7 again, 8.8, 7.7, 3.2, 5.4, 3.8. So assume that the paired data, okay, the paired data came from a population, that is normally distributed. Normal distributed. We would like to find S sub D. So to find SD for these two data is going to be the square root of S1 square over N, call it N1, plus S2 square over N2. So N1 and N2 are the size, like how many in each. There's like 5 in each, 5 datas. Now, how do I find the S1 and S2? So S1, we can use the formula, the sum of xi square minus the sum of xi all square over n all over n minus 1. You can use this formula, or S1 is the square root of the sum of xi minus x bar square over n minus 1 for the samples. So here we have 5 values. If you want to use the second equation here, so the way I like to do it, I take these values, those 5 values, and first value 2.3. So these are the x values: 5.7, 8.1, 4.4, 4.7. Then x bar, the mean. We have to find the mean for this. So the mean, you all should know to find the mean by adding all of them. 2.3 plus 5.7 plus 8.1 plus 4.4 plus 4.7. So the sum of all the x's is 25.2. If you divide that by 5 quantities, the mean is 5.04, 5.04, 5.04, 5.04, 5.04. Then you do x minus x bar. We have to subtract them. -2.74 negative 5.7 minus 5.04 0.66 8.1 minus 5.04 3.06 4.4 minus 5.04 negative 0.64 4.7 minus 5.04 negative 0.34. Then we have to square that. .5076. 0 point if you square this. A calculator is needed for the final. 9.3636. Zero point 4096. 0.1156. Done the sum of the xi minus x bar square, I get 17.832. If I do put that in the formula, 17.832 over n, which is 5 minus 1. So this is like dividing by 4, you get this. And the square root of this is 2.11. 1, I think. 3. That's for the standard deviation for the first one. That's the standard deviation for the first one. Now, you can do in a similar way, you can find S2. I just found it, it gives me 2.4252. That's S2. And now to find SD, again the formula is S1 squared over N1 plus S2 squared over N2. 4.458 over 5 plus, if we square this, you know, the 2.4252, you get about 5.8815 over 5. Under the radical, we get 2.067919. Which is about 1.438. We're still in the same problem, but recall this means the mean of a population. This mu is simple mean. And in this chapter, when we learn about two dependent samples, so this is about two dependent samples. Some people call it matched pairs. And so we use several notations, just so you know. Mu sub d stands for mean value of the difference, or difference is d. for the population of all matched pairs of data. We use what we call it the t value, or t distribution, or t sub 0. The formula, if you guys remember, d bar mu d over sd divided by the square root of n. So that's what mu d is, and d bar is the mean value of the differences d for the paired sample data. And you know, n is the number of pairs of sample data, and as the standard deviation of the difference. So let's say use alpha 0.05. We need to test the claim. That mu sub d is less than 0. Mu sub d is less than 0. You know, when we test claims, there's null and alternative hypotheses. So the null hypothesis is where mu1 minus mu2 is 0, or mu d we call it is 0. And here is given mu d is less than 0 for the alternative hypothesis. So we need to find t sub 0. T sub 0, the critical value is d bar minus mu sub d over sd divided by the square root of n. Now let's see what do we know, what is given and what is missing. What is missing? Now, so this one, you know, mu sub z, this is 0, this part. You know what n is, 5 values. We found sd in the first part from previous part. The only thing we left to do is find d bar. Let me show you how to find d bar. I'm gonna scroll back up to the table. So from the table we have here, I'm going to create another row. That row for the D row. And what's in the D row, we subtract them. The first value minus the next value. That gives us negative 6.5. Okay. Then we do the same thing for each one of them. This is negative 2. Then you do 8.1 minus 3.2, 4.9. This is negative 1. If you do 4.7 minus 3.8 is 0.9. Now from here we need to average these values. We need to take these values and average them up. Okay, average them up. So let me see. So
So I found the difference values. I'm gonna rewrite them again here. Negative 6.5, negative 2, 4.9, negative 1, 0.9. We found all of them. And from the D values, the difference, to find the mean, we add them up, plus negative 2 plus 4.9 plus negative 1 plus 0.9 divided by 5 of these values. So now we are going to calculate all of this. 4.9 plus 0.9 minus 2 minus 1 minus 6.5, negative 3.7 over 5, negative 0.74. This is the value for D bar. So this becomes negative 0.74 over, I'll scroll down, let you copy in a minute. Let me see, that was 1.438, 1.438 divided by the square root of 5. And we are going to calculate this. Now the top stays as is. If you like to calculate the bottom, is 0.643093, and now about negative 1.1506. This is the, we call it the T statistic value. T statistic value. Next, so we found the test statistic. Now we find the critical value. Critical value using table A3 with alpha is given 0.05 and the degrees of freedom 5 minus 1, 4 values. So if we draw it this way, 0 is here. We find the critical value. The critical value was negative 1.15. They ask us to test to the left. Now we need to find again the that's not a critical value, that's statistic value. Wait, here we usually put we put the critical value, which I will find in a minute. Wait, critical value, and then check where the test statistic is. So I'm looking at the table right now. It's 2.132. So in this case we'll put negative because it's to the left. This one, this is the critical value, and the value that I got for test statistic, negative 1 point something, which is here. This is negative 1.15, let's say. So this is the test statistic value. Note, in this case we fail to reject the null hypothesis because the test statistic T sub 0 does not fall in the what we call the critical region, which is the shaded region. So how do we get the critical value? Here we have degrees of freedom in table A3, table A-3. It's called the T distribution values. or the critical t values. So here they have like 0.01, 0.02, 0.05, 0.10. Those are for two tails, but if we're doing one tail is going to be up here, 0.05, 0.025, 0.01, 0.005, like that. So here they have 1, they have 2, they have 3, they have 4, they have 5. These are degrees of freedom. So to us, we have to go to the table with degrees of freedom 4. So if I'm highlighting this way, and then it's a one-tail test because it's set to the left, right? To the left. So you're going to take this one and go vertically down in that column. Okay, in that column down. And where do they overlap? They overlapped here. If you look that number up in the table, is 2.132, like that. Just so you know, on the test, we give you the yellow formula sheet. Table A-3 is the same as table 4. It's table 4 is there. So here we take another example. Say one person is randomly selected using this table below. Let's classify them as men, women. And what do we need to talk about? Maybe teachers, tech support. Let's talk about farmers. Say we have 20. We have 15. 5, 15. Or let's make this 35. Farmers, 10. 5 again. So find the probability that the person is teacher or man. Teacher or man. So here we need to find totals on this side. This is 55, that's 20, that's 15. If we need to find total here, 10, 30, 45, 45, 90. So a teacher or man. So it's basically, or means union. So how many, what's the probability of teacher plus the probability of man, but it could be man and teacher at the same time. Mine's the probability of teacher and man. Teacher is 55. Right, teacher over the total is 90. Man, how many men we have? 45 over 90 minus how many men and teacher? 20. And I'll let you finish this up. Another part. What's the probability? Let's say women and farmer. Also, what's the probability of man? Women and farmer at the same time. That's 5. Make sure you reduce this, by 5, whatever that is. 18. Man, what's the probability of man? How many men are there? 45. Total 90. So the answer is 1/2. Make sure you simplify. One other part, probability women given tech. So the slash means given. So that tells you that can be found the number of men and tech at the same time divided by the probability tech. Tech and women, let's see how many we have. Tech and women, it's 5. Okay, it's 5 over 90. Tech, there's 20 tech over 90. These cancel, so you get 5 over 20. 1 over 4. All answers must be in simplified forms. Make sure you know the shapes of distribution. Like bell shape, skewed to the right, skewed to the left. Uniform. Make sure you know the sampling techniques. Make sure you know the empirical rule. And how it is used. The empirical rule is the one that goes like this. Like you have the mean here, mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, mean minus 1 standard deviation, mean minus 2 standard, mean minus 3 standard deviation. Look into this. There's a data that shows you what percent in each one falls in each one of them. So look for the empirical rule. Make sure you know the empirical rule and how to apply it.
How do you find where the inflection points are?
Next, make sure you know how to work out test hypotheses for 3 means, let's say. 3 means where we set like h0 mean 1 equals mean 2 equals mean 3, and alternative hypothesis at least one mean out of mean 1, mean 2, mean 3 is different from the others. That's where the F statistic value is used. Make sure you go over some examples related to population proportion. Where you have to find point estimate, find the margin of error, find confidence interval, and find the sample size under the given conditions.